Put it all together and whatever you get, it's new math. It's new math. And what's a bag?
Now I want to discuss how to get the tan graph. First of all, we need to know what the tan equation is. Sine x over cos. And then we know the tan equation is equal to sine over cos. After that, I want to set up a value table like this. X and y value. And then I start to write down the special triangle. 0, 30, 45, 60, and 90. Why do I want to use the special triangle? Because I can get the answer easier from the special triangle, like 45 degree, 45 degree, and 90 degree. So we know the baseline is 1, and then the opposite side is 1 as well, and then a hypotenuse is √2. This one is 30 degree, and this one is 60 degree. So we know the baseline is 1 as well, and we know the opposite side is √3. The hypotenuse is now we want to start to get how to get the value y value from the special triangle. Like tan is equal to this side over adjacent side. So we take the 30 degree as the example. Tan 30 is equal 1 over √3, which is the approximate number is 0.57. Right now, we just start repeat again the calculation. As we know, if the divisor is 0, which is the result is 0 as well. So the 30 degree, we get it 0.57. And 45 degree, which is the 1 over 1, is a 1. And then 90 degree is, we can find it as well, so we put it into NA.
Alright, so we're going to talk about how to graph one of these tangents. So we're going to use probably the most simple one, which is y equals tan x. So as you can see on the graph, we have all the special angles on the x-axis, and then on the y-axis we just have 1 and 2 on the top and -1 and -2 on the bottom. So as Kevin did before, he wrote out the table on the side with all the special angles and each of the parts. So this is the easiest part. All we have to do is just label it in. So 0.57, I would say it would probably have to be somewhere around here. 0.0 also. Then 45 degrees, I would say that's around here. Then 60 at 1.7, that's around 2. Now 90. So because it's infinite, you can't solve it. It is the vertical asymptote. So we just want to we just want to make a visible line here to show that this curve will actually not even touch 90. And then we do this on the same side. If you were to put all of the x's as negative numbers, it would be the exact same numbers, but except it would be negative. So instead of it being 0.57 for 30, it would be negative 0.57. So that's actually around 30. That would be like around there. At 45, it would be at 1. At 60, it would be at 1.7. So I guess it would be right here. And then 90 is also the vertical asymptote because it still won't be able to solve for it. So we just kind of want to make it. Now you just want to connect it. So you kind of just want to draw a curvy line going from down, cross, and to there. And then you just kind of want to go same, and you're just going to travel upwards. So we just want to show that it's continuous.
The 6 main stats we need to discuss
for the tan graph are the max, the min, the domain, the range, the amplitude, and the period. Because the tan graph reaches an infinite value, there is no maximum, and because also it reaches a minimum value, there is no minimum, or an infinite minimum value. There is no minimum. The domain is x. It can be all real numbers, except x cannot be 90 degrees, 270 degrees, continuing on that pattern, increasing by 180. That's because of the period. The range is y, can be all real values, because y reaches, because the graph reaches an infinite y value, as well as in the positive way and both in the negative. The graph also has no amplitude because of this, and the graph has a period of 180 degrees because it has asymptotes at both negative 90 and 90, and in radians, this is just a pi radians. Is that your pi?
It's a pi.